So here we have a user. We know how we're going to address users. We know what their IDs are going to look like. And our goal here is to build a web service. Where do we start? Right. The second person that's gotten that right. Out of all the people that I've asked, what was the answer? The answer is you start with a test. We're going to come over here. We're going to write a Spock test. We're going to pretend that we're all really good Agile developers. We're going to write a test first. Right? We'll build, it's going to be Groovy, so we're in test now, so we can do away with Groovy, because our bosses don't care what we test with, they just care that our stuff is Java in production. We'll just build a system. We're not going to get too nitpicky, not going to do a lot of unit testing. This is going to be an overall test of the system to make sure that it behaves the way we expect. Make it a Spock test, we extend application. Now we have a Spock test. And we can start testing. We can say, for instance, users can be created. Place to start. I would like to say when I create a user named Bob, then get some response from it. And here we're talking HTTP. REST, of course, typically deployed in HTTP. That's pretty much universally accepted. We're talking about an HTTP response here. So we're working with HTTP requests and response at the kind of mediocre level. Not getting in too deep. But when we create something, the response status should be 201. For any of you REST guys or people that don't know REST, 201 means created. It means the server accepted this request to create something, successfully created it, you're good to go. Also, as part of the 201, the server is required by the HTTP spec to return a location. Because when you tell it to create something, you might not have told, you wouldn't have, okay, phrase it, should have gone into a little more depth. Let's back up a little bit. We create things with this ID right here, because we're saying, create a new entry in this collection. You wouldn't give it this form of identifier because, one, you don't know what the ID is, because most likely it's being generated on the server. So you can't create there. You create here. And if you create here, and your user actually lives here, you don't know that unless the server tells you. And that's what the purpose of the location header is. Responsive location will contain the identification of the user that was created. Of course, we can't predict what it will be, but at least we can say it should be null. So it should at least have a location. We wrote a couple of helper methods there, specifically create and user. I'm going to fill those in now. First of all, we should be able to create a user. To do that, we're going to have to make a REST call. So this is where the Jersey client comes in. Jersey client, pretty handy little guy. It's basically just an HTTP library, but it's geared specifically toward making RESTful, doing RESTful things. So I can create a client, like so, and say I want it to be based at some resource, and I need a URL here. I don't know what that is yet. We'll get to that in a minute. But this is saying, basically, give me a way to interact with the thing that's running here. And whatever that URL is, the first part of that URL, that's what we want to put in there to create the client. And from there, we can interact with all of the branches, the sub-resources of that URL. Make sense? Okay. There's my client. Build client got a resource from. Then I can say with my resource, I want to go to the path users, because that's where it says our users collection list. So if this is the base URL, then we're going to the thing that's looking at users, which would be the collection of all users. I want to send it something. I want to send an entity. Entity is referring to the entity of an HTTP request or response. Request in this case. So I want to throw the user in there as the entity of this request. I need to tell it how to represent the user. So we're back to representation. In this case, I'm going to say we want to work with JSON. And to do create, to request the server to create something, we do a post. That was something I probably should have mentioned earlier. Most of you guys are familiar with REST, so I kind of breezed over it. I didn't really think to mention it. But our 4 verbs that we use are post, put, get, delete. Corresponds to, doesn't matter what kind. Post is a create, put is an update, get is a retrieve, and delete is a delete, obviously. So when we do a post, we're saying create this thing at this location. So we're saying specifically, go to this collection of users, and add this user. And it says I'm sending it as JSON, so that the server knows how to interpret it. So that's my representation. Now this post method here, there are a few methods like this. You guys see that okay? It's kind of small. Good. Okay. There are a few methods like this in the Jersey client library that accept several different types of things. And they're kind of a little bit magical, and they're really awesome. You can tell Jersey what kind of thing you want to get back from sending this post. You can say, one, I don't care what you give me back. And you just say no, if you do the no parameters, the top one, they just won't really give you anything back. If you say, I want a particular thing back, like I could request the user back. And then it will read the response and try to interpret that response as a user, which obviously probably wouldn't work here because we wouldn't necessarily get a user back and create a response, although we might. You can also say, I just want to get the raw response back. Client response is basically a raw HTTP response. So you can grab it, you can do assertions on the status code, headers, and whatnot, like we did right here. So that's the option we're going to choose so that we can actually check that we're getting the right stuff back from the server. You'll see more examples of some more powerful steps here later on. We'll get to that. Okay, and then finally, that's our create method. We also need a little factory for users. We give a name. I can return a user. That's just a fancy little piece of Ruby syntax that kind of fun to use. Neat to show off. Good to know about. Very useful. Let you build objects with, I should say, user name. And it puts this object in scope inside of this closure, and then lets you manipulate it as if you had said user.name. The clean syntax of what we use. Okay, so now once we figure out what our base URL should be, we would have a runnable test. And we could run the test and it would appropriately fail until it was stupid and not have a server. But while oftentimes it's good to switch between test and main source, bouncing back and forth, write a test, make it pass, write a test, make it pass. For continuity's sake, I'm going to stay in test until we've completed the whole test suite for this talk, and then we'll move over to the main source. So let's keep going while we have some momentum. So once we can create a user, we should probably say that creating 2 users with the same name is complex. We can express that as I create a first user, then create another user with the same name. First response should be 201. Second response should be 409. 409 is HTTP conflict. Server saying, couldn't do what you asked me to do because I had some internal state that conflicts with what you told me to do. Now this test introduces a constraint which is actually going to affect our test overall. If we were to make this test pass, we're saying we can't have 2 users with the same name. Up here, we've already created a user bomb. So now you're getting the problem, I'm sure everybody's experience of test data stomping all over test stomping all over each other because there's persistent data stored somewhere. Because this is a pretty high level test. We're not assuming, I'm not assuming here, that I have any easy way to clear out a database or reset it to a known state or anything like that. So we have to handle it some way. Easy way to handle it is to introduce a little bit of randomness in the test. Say randomness. And there's some randomness. And so I can say, instead of Bob, kind of Bob. He's also a Bob. Now, I can get away with that. This might not be immediately apparent to any of you, or some of you. I can get away with that because it's based on JUnit. Spock is based on JUnit. And in JUnit, and pretty much every XUnit framework out there, a new test instance is created for every test method. So this randomness field is going to be initialized one time for every test method. So in the scope of a test method, it'll be the same. But between two test methods, it'll be different. What I've written here is essentially the same as if I'd done setup, which is Spock's before method. Did that. Okay. It's just a matter of test initialization. So the field will be initialized slightly before the setup method is called in the life cycle. It's also a little prettier, so I've written that. So now we have randomness. Our tests won't interfere with each other. Our complex tests should be relatively happy.
So I mean, 409 will always be and when you can get a 409 back.
So now you're talking HTTP semantics. REST is very heavily HTTP, very intertwined. 409 is just, that's an HTTP spec. It's a conflict. We can look up the spec definition if you want to. Something like a database being down would probably be more of an internal error. That would be a 500 series of error. So a 400 series of HTTP error means that you, the user, made some bad request. And you should reformulate and try it again. So database being down is more of an internal thing, like I'm broken and I can't do anything right now. That's 500 series.